Today's Business Intelligence Virtual Chapter session. We're glad that you have joined us, and I apologize about the delay, but we are going to get started right now. Just a couple of things to mention before we turn it over to today's presenters. Our virtual chapter presentations are sponsored by Pragmatic Works, and you can always grab a copy of the previous sessions by going to the bicqlpass.org site. And there's some ways that you can drill into seeing the prior presentations. I know a few weeks back we've had some technical difficulties, and some individuals have had trouble hearing and then trouble seeing the presentations, but hopefully all that has worked out, and going forward we'll be able to do good presentations. The presentation in question was one by Jen Stirrup that really was the one where we had the most technical difficulties of, but the slide deck is available at the link noted on your screen. The couple of things that are going on in the future, and you'll notice that some of these have already taken place, but they gave us a whole slide deck of SQL Saturday events that are happening. You can see it all throughout the world for you to register for. Also, we have several virtual chapters. There's tons of meetings that are going on. I highlighted down the very bottom there a couple of the chapters that are going. Couple of chapter presentations that are going to occur later in November. All the rest have already occurred in October. Here's just a quick listing of everyone that has a virtual chapter set up, and you can see it covers the gamut of both locales and specialization. So be sure, outside of the Business Intelligence Virtual Chapter, go ahead and join some of the other chapters that are out there. The other thing that PASS would like us to pass along is make sure that if you have someone from a volunteer standpoint that you would like to recognize, there's the website and the email address that you can use in order to nominate someone for a volunteer of the month is basically what they do with that. One last thing, announcement before we're going to turn it over to our presenters. Basically, we have the Business Analytics PASS Summit. It's just like the PASS Summit, except for it's for business analytics only. They're still looking for folks to join the summit, and so make sure that if you have an opportunity to head out to San Jose, California in May, that you go ahead and do that. Last couple things about SQL Pass. There's a LinkedIn site, Facebook, Twitter, and then the blogs at sqlpass.org. So today's session, what are we going to cover? Basically, today's session is going to be a data warehouse architecture, and we have Jeff and Leslie are going to present today. I'm actually going to let them introduce each other and themselves. They're both out of Denver, and so what I'll do is I'll go ahead and turn the presentation over to them. It'll take us a second. I've got to make them organizers so they can share their screen and such, but once I do that, they'll be able to go ahead and take over. So give us just a second to make that transition, and then Jeff and Leslie will be able to take over.
Thanks, guys. Sounds good.
All right. Y'all should be presenters, so if y'all could go ahead and switch over to your screen.
Okay. So let's just get this set up here real fast. 1 second. Oh, this is not my screen. Okay, there you go. So you should be presenter.
And there we go. I can see y'all's PowerPoint, so we should be good. We appreciate everybody hanging on while we're doing this. Again, we're working on the technical issues with each time, so we're good to go here. So that's good. Good news. I can see the PowerPoint, so you're good to go.
There you go. Move it over. Yeah, I don't know why you have it on this one, but you should have it on that one. Sorry, everyone. We're just trying to figure out which screen is showing up here, and it doesn't appear to be showing up the right one, so let's just get this fixed real fast. There we go.
All right.
Okay, here we go. So,
thank you for joining us on the webinar. I'm Jeff Renz. I'm a consultant with RevGen Partners. I've done SQL for quite a while. Definitely had done quite a bit with data warehousing. I had experience with some Data Vault certification training, so I'm really excited to share some of the details from some implementations and some things about Data Vault.
and I'm Leslie Weed, and I'm a consultant at RevGen also. And I've been doing SQL for over 13 years, and Jeff and I had a fairly large project, and we went down the Data Vault route, and so we wanted to share that experience. We think there's a lot of good things about it, and we think it's beneficial to share that so everybody has this kind of a concept in their toolkit.
So sort of what we're going to talk about is enterprise data warehouse architecture at a high level, how Data Vault fits into your design for your data warehouse. We have some Data Vault examples with some American NFL football data. We'll sort of go through the Data Vault definitions and terms, and then Leslie will share some of the details when we implemented the Data Vault architecture at Bound Solar.
So to start off with, one of the challenges we had when we were working at the solar company was we had to come up with a better system than what was running at the current time. We knew we were expanding. We had a lot of challenges, a lot of IT challenges when it came to how we were going to model things. So after we went from a Thor normalized form to a Data Vault form, our systems guy came back and gave us these stats. And this was when these two systems were running in parallel, and the Data Vault was actually on a slower performance machine. So by the numbers, this is kind of our tickler slide. This is kind of like, wow, we really improved things via this model.
So another project where I implemented Data Vault architecture was for College Invest. They had an issue where they had a lot of complexity in their environment with a lot of different database systems where they had similar data and were storing it more than once and had lots of issues. And one of the developers had lots of synonyms, so it was very interesting that they implemented that way, but in the end, using Data Vault, we were actually able to replace the 8 databases with one, and we eliminated the need for the synonyms that were originally implemented.
So as we talk about an enterprise data warehouse, and this is where we really are supposed to bring out the Star Trek enterprise symbol here, but what we often talk about is a lot of times we don't realize what enterprise means. And in a data warehouse context, what we mean by an enterprise is that we have more than one source of data. So it's not just your financial data, it's not just your manufacturing data, and not just your shipping data. It's all that data coming in so that you're really getting an overview picture and bringing all of that data regardless of that source system. So we're providing a single data repository. We're integrating that data. This helps us facilitate reporting and really allows us to get in that position to provide management those KPIs and those wonderful pie charts that they love. And then one of the great things about the warehouse, we often need to do that auditing and that historical piece. So that's where our warehouse comes into play oftentimes.
And from my point of view too, if you really need to audit and track data, there's different techniques for doing it. But I feel Data Vault offers a faster to implement and a pretty easy way of doing the history.
So for data models, again, these are more of the common ones that we work with in multiple platforms, not just SQL, but also in Oracle, where we have the third normal form. We kind of tend to see that is optimal for operations, operational systems, transactional systems. Data Vault, we kind of see that optimal for a data warehouse because of that auditing in the history. And then the star schema, that more of that Kimball style, where that really allows us to do that OLAP delivery, the marks. So just kind of a general picture so you can keep it in mind of how we kind of think of an architecture in a system. And this is not going to be true for everyone's environment, but just kind of a general idea where we say, okay, we have a lot of data sources. They could be various different platforms, flat files. Typically, we ETL that into staging, possibly not staging, into our data warehouse. This, as we talk through this presentation, that is where our Data Vault model is. And then from there is where we go out to more of the organization to specific business delivery with the marks, the cubes, the tabular, out to reports.
And I think just from experience, there's a couple of design patterns and things that you could consider with your staging database to help you load some of the Data Vault objects in parallel and preference from the data sources when your data is coming in. And some techniques you could use if all your data isn't arriving at the same time on your ETL. So there's some additional things you could do with that. And again, to sort of highlight, the Data Vault architecture itself lives in your physical data warehouse where you're integrating your data together. And then that sort of allows you on your data mart stores to design your star schemas for the business and only put the data in you really need. So all the history and all the other stuff you really need exists in the data warehouse.
Right. So one of the questions we had come up is, what type or types of analysis are the structures created by Data Vault methods optimized for? So Data Vault as a whole structure for your data modeling concept is really the behind the scenes concept. And we'll get to another piece where we talk about the back end, the closet versus the front end, your reporting and where you do your analysis. So the Data Vault, the data warehouse is really that back end. You're not going to do a lot of analysis there.
Yep, and in the case, let's say you had your data warehouse. I have actually had people in the past suggest, is there any best practices you might do with Data Vault if you were to directly create a cube off of the data warehouse? And simply I think it's a good practice to use database views on top of your warehouse to logically put some data together for cube consumption for your tabular models, for example. So that would be one of the patterns that you can do if you had to do that.
Okay, so let's talk about a data mart, and this is that delivery. This is where more of our analysis is going to come up. We see those data marts are going to be specific for parts of your business, the sales group, the manufacturing group, the financial group. So we kind of separate those data marts out for your specific line of business. That allows your reporting and your infrastructure in those and that modeling to happen specific for those business to where you can add additional business logic there if you need to. This allows that kind of creates then that point of it's a layer above your warehouse where regardless of the changes that you're making in your warehouse, you're not affecting your data mart if you develop correctly. So you're allowing this meta layer to happen so that you don't have people querying directly against your data warehouse. And this is an important concept, and this is what gotcha. A lot of times where we see where data warehouses have failed and become problems is because there's a lot of touch points going on directly to the data warehouse itself, which becomes a problem.
And one of the key concepts with Data Vault is when you're loading the actual data warehouse, you're really not transforming data and applying lots of business rules to your data. When you're creating your data mart, that's where you might filter data, change the data around, and save it in a new format. So if you ever had a business rule change and you needed to go back to original data, you leverage your data warehouse where your original copy of your data is at, and you could redo your business rules and filters to repopulate a data mart without losing history and original information.
Okay, so we're just going to quickly talk about dimensional modeling, just so for a reference, because Data Vault is a modeling concept. So we're going to compare it to dimensional model as a concept so that a lot of times you are familiar with one and you try to think about how to learn the next one. So quickly remembering a dimensional model, you have fact tables and dimension tables. Your fact table holding the business facts, the dimensions being descriptive information, attributes about those facts. Okay, and then typically when we look at that star schema, here's another, just so you visually remember star schema, how this looks like, because what you're going to want to do is you're going to want to compare it versus the Data Vault and how that model looks. So there's quite a bit of significant difference. So just kind of remember, here we've got the facts and the dims. And one of the things that we do, you'll see we have player game and player and team and season. So our presentation comes off of the NFL data. That is American football from SQL Azure. We downloaded a data set from there. So just to know what we're familiar, what we're working with, it's that football data.
And really again, data warehouse would feed your data mart, so you would have original copies of data there. But if you take a quick look at what we have in the dimensional model, you'll see there's a whole bunch of statistics, and it's sort of cropped in here on defense and offense if we scroll down, and we'll get into that later. Sort of some grouping in the hierarchies with the calendar and some implied things like the NFL football week, and then with your season you'd have properties like some Super Bowl details, things like that.
Okay, so this is more, again, back on the delivery side, what we're doing after the warehouse layer and things you can do from that end with the multidimensional modeling, the OLAP, and then the tabular modeling. Just a reminder that, you consider that the BI semantic model post the warehouse. That's that next layer. And then we get to Data Vault, so the Data Vault modeling concept. So this is going to be very detail-oriented, historical tracking, uniquely linked set of normalized tables that support one or more functional areas of business. So it's a modeling concept. A lot of people consider a hybrid between third normalized and Kimball, or third normalized and stack dimension. So this is one of the quotes we came across in one of the blogs that we thought was really interesting. So again, Data Vault, that data warehouse, Data Vault is our back room. It's where we're going to collect and integrate and preserve data from all our source systems and let that history live in there and that strong tracking. Then the dimensional model, which is that next layer, which we talk about for reporting in the data marts, that's our front room. That's where we're going to allow those effective support decision making to happen and really have that data specific to organization needs.
And one thing, when you look at the design, when you're creating the back end to organize the data, one of the things we're talking about is efficient. We want to add data quickly, join different data sources quickly. We want to be agile. So, from experience, I feel that the Data Vault architecture gives you the ability to integrate data really quickly with the structure so that you're efficiently collecting data, so then it can be brought to the front room when you're modifying your data marts for presentation. So getting into Data Vault, there are three key concepts that you really have. You have hubs, which are your business keys. You have links, which are the relationships between business keys. And so, and the satellites are descriptive information. And that's it. There's a lot of rules around what you put in as a business key, how you determine the relationships between your business keys, and then satellites, the details about the hub, about the links, and about the relationships. So if you take a look at this picture, you notice everything is connected together. So that's the point of the warehouse, is that you're going cross systems and you're finding a design pattern so that the data does fit and connect together. And so taking a closer look at your relationships that you have between the simple order details, you're going to have a customer. So there's something that's going to identify what we call a business key as a customer that would be across your different business systems. And so that becomes your business key. Then you have different properties that would be put into the satellite. Again, when you have a product, you're going to have something that uniquely identifies something that you're selling, and that is your business key with properties around it in the satellite. And then you have an order. So when an order is created, you're going to have something, again, unique that will track the order. And then those three things come together in the link table. You're connecting something to a specific customer, specific products, and orders together, and so that's your unit of work, and that's what would tie in the sales order together.
Right. So if you're thinking about this compared to the fact of dimension, it's not a one-to-one as far as table structures go, right? I can't make my dimension a hub. I can't make my single dimension into a satellite table. What you're going to find is that dimension and that fact actually breaks out to be several sets of hub and satellite and link tables.
Yep. That's true. And so the dimension could come across satellites from other business keys via the link. It just depends on what your model is for your data mart. So what we'll do is we'll shift gears into SQL Management Studio, and we'll just give you a quick little highlight of some of the relationships that we have and some of the naming standards that we would see in the database, and then we get back into more of the definition of what those objects are. So what we have in our NFL database is a bunch of hub, link, and satellite tables. So we have hub type, players, seasons, teams. So if you sort of remember what we had in the star schema, they're close but not exactly the same. That we talked about the relationship, a link between a player game. So we would see we have player names with sequence numbers, we have game types, etc. If we were to look at a hub table, we're going to see, again, a sequence number. We're going to have like a game type, LVTS, RS, which we'll get into in a minute what that means. Typically, when we're putting together what player stats would look like, zoom in a little bit. So we're going to see a bunch of different details about the league player game. We're going to have satellite for the game. We have defensive, offensive, etc. So that's sort of a quick peek at how these are related together. Leslie, anything else to sort of highlight off the bat? Yeah. So key concepts, so you sort of got a peek at how we made our database. When we're thinking about what we're putting into our hub tables, when we're talking about business keys, we're looking at something that's identifiable to the business. So when you sort of, maybe from the database side, you see internal field names, GUID sequence numbers, things like that. Those aren't really business keys. What you'll hear business users talk about is like a sales order number or a customer number or a customer name. Those are your candidates for your business keys. Those are the terms that allow you to connect your data together across the systems. So when you know you're on track for a business key, they have the propensity or a low propensity to change, where you have a sales order. That sales order represents that sales order. You have a customer number that refers to a customer. That doesn't change. If you think you have identified a key and it actually changes a lot, that probably isn't a business key. It really, for the most part, business keys don't change. There are some people that have implemented Data Vault and they've had a couple keys change on them, and they asked, how do you handle that? So again, there's some stuff that you might do in your staging layer where you have a reference table to say I have an old key that doesn't exist, and you might map it to a new key name if you ever got data in. So, there's some tricks to deal with that. But again, ideally it would never change, but in real life, every once in a while a key might change. So when we're thinking about finding a business key and we're looking at NFL data, some of the options available to us are when we exported the data from the stats database, they gave us a team ID, they gave us a team abbreviation, they gave us a team name and a team nickname. So when you're thinking about talking about your sports teams, what I say, team ID, and I'm going to talk about the Broncos because I'm from Denver and I really like the Broncos. I wouldn't say, hey, team 332 had a great game. That's not going to happen. So,
or how about DAL?
DAL, yes, or DEN had a great game. You probably would see that on a sports ticker.
Sounds like airport code.
Yeah, and you think, hey, I'm flying into a code now. You're going to call it out by the name. So at least on Denver, you could say, we're going to talk about the Broncos, so we could call them Denver or we could call them the Broncos. So narrowing it down, we're going to say, hey, what about if we're dealing with a team from New York? Well, you could say New York played a great game, but you have the Giants and the Jets. So the concept of a business key is it's uniquely identifiable. New York isn't uniquely identifiable because they have more than one team. So you look to see at the team nicknames. So you see the Giants and the Jets. So in this case, when you're creating your business key, the proper key is the nickname, Giants and the Jets, and that would appear in our hub table. So looking at the data, when we actually create a hub table, we have team SQN. So SQN is short for sequence number. So in every single data vault table, you're going to have a sequence number generated, and that's what you're tying together between your links and your satellites and your hubs. So every table will contain that. In your hub table, you'll have your business key. In some cases, you could have a composite business key. That's appropriate. Most of the time, it is just one field. And then LVTS is short for the load date timestamp, and RS is short for record source. So one of the really important things with Data Vault when we talk about auditing and history and tracking is whenever you load any Data Vault object, you're going to put in a load date timestamp and a record source where that data had come from. So if you think about, you want to load a data mart with data, and you don't want to do a full compare what's in your data warehouse to what's in your data mart, because every object is being timestamped, you're going to be able to do incremental loads from your data warehouse into your data mart on change data. So this is a really good thing. Another thing why we would have the record source is if we're truly having an enterprise system and a business case could come in from more than one system and we added something to the table and it doesn't feel like a business key, we would know where that had come from, and so maybe there's an error or a problem in a source system. So it's our.
So one of the nice things about Data Vault is with these very strong rules of, some people call these the hoodoo fields, our sequence, our load date, our record source, or load end date type field. With these strong rules, you have a real stronger propensity to have a consistent model. A lot of times you come into organizations, especially with third normalized, and you've got table structures that are all over the place with all sorts of different concepts. So one of the great things about the Data Vault is the real strong rules. You know exactly what columns you have to put in there and exactly how things need to match up.
Yep. And then there are strict rules again, and you never join a hub table directly to a hub table. Part of, again, when you're trying to load a data warehouse really quickly is you're looking for parallelism and loading data quickly. So part of the ETL process would be all hubs are loaded in parallel inside your SSIS sequence container, so you achieve really quick loading on your object. So that's one of the rules to support that. Again, a link table, I mean, it's pretty straightforward. You're associating two or more business keys together. You want to think about what comes together to create your business key to reproduce your data. Hubs, and you can link to other link tables, but through experience implementing things with Leslie, it becomes far more complicated if you try to link tables. And then when you're thinking of loading a data warehouse, you're searching for parallelism on your loads. And so if you don't link table, but create your links to your hubs, you can, again, load all your link tables in parallel when you're processing and loading your database. If you start putting dependencies across link tables, then you have to remember that in your SSIS package, or you're going to have some problems when you load your data. So an example that we have in the NFL database is that we're connecting for a team game. We have a season that we're playing in. We have a team and then opponents who you're playing against. So from an NFL football perspective, you're saying season, I'm not quite sure why that's important as a business key. One of the things that you'll notice about a football season is that the season doesn't end December 31st. There's some playoff games in the Super Bowl in January and February, so that's considered part of the season. And when you talk about statistics, you'll compare maybe a player's statistics across seasons, and so it's referred to as NFL seasons. So then in the satellite table, we're going to have descriptive information about the business keys. So I think one of the things that is a hard concept for people that haven't worked with Data Vault before, I just want to add extra columns into my hub table. I just want to do it. What's the advantage of having another table? Well, when we're trying to record the history, this is where we keep track of the changes as in the satellite table. So if we have something that changes, like the price of something, or you have a product that you're selling and maybe the color or something, or your product description, it'll be a description for a while, and then it will change one day. And so you want to know when that had changed and what it was in the past. The satellite table supports that. The other thing that satellite tables support is if you have a field or two that changes every day and the other fields don't change, you could actually split the satellite and put the data that changes really rapidly in a different satellite name. So it supports the history, and then you're not having a lot of redundant data. So in the case of why would we care about history, last year there was a very upset Broncos fan that the Broncos lost their playoff game, and so they came in and they hacked the database, and they called the Denver Broncos the Donkeys. So what you can see with the load date timestamp in the satellite is the first record was loaded on the 14th at 9:24. It was set as the Denver Donkeys. The LED timestamp is very specific to the satellite only, and that's the load end date timestamp. So when you're looking from a point in time of how data was set, you'd know from the 14th of January to the 16th of January. If somebody came to the website and were querying Denver, they didn't see Denver, they had seen the Donkeys, and the record source had come from an upset fan. On the 16th, it was changed back to Denver. So that gives you your auditability that 2 days somebody hacked your database, or somebody goofed the data up in your database, and it was set that way.
Donkeys.
Those donkeys.
So this is the reason why this is a popular modeling technique with the financial institutes, because it's such strong auditing.
Yep. And it was also, when I worked on the College Invest project, that was an important concept too, because we were getting hours in from the colleges, and administrators could override college hours, and there could be auditing from the state. So we wanted to keep track of who had changed what. I think there was some stuff at Abound too that was important.
Yep.
So then one of the important concepts when you're modeling is a unit of work. So you really do have to think about all your business keys and how they come together to create that proper relationship. Because if you have more than one business key and you leave that out of your data warehouse, the goal would be to reproduce the original data from the source system. So if you had a sales order system or something, and you wanted to purge data out, your goal of your data warehouse is to maintain all that original data so that you can decrease stuff in your operational systems. So the unit of work is the thought process around a set of data, including the descriptive information about this. So one of the concepts we have here with football is that from time to time a team might change names, and a team might change cities. So in this case, we see like in a team abbreviation or nickname might change. So we had seen some stuff like when the Houston Oilers went to Tennessee and they became the Tennessee Titans. We would see that in one of the satellite tables when it had changed its history data.
So as we look at the data vault, and I think maybe we should go back to SSMS and show some of those examples and show the joins and how those views work. Just to kind of get that idea of how things are really coming together as we start to query against these items.
An example, when we look at the season, we just basically have the season year. So we would go through 2012, we'll have 2013 in at some point. So that's really at the business key is the season. We have a load date timestamp and a record source for that. If we look at the satellite for the season, some of the seasons we put in details about the Super Bowl. So every season you're going to say where was it played at, what was the stadium name, what was the Super Bowl date, who was the MVP of the Super Bowl, and then the record source was actually website NFL with Super Bowl history, where we got that from.
And so this is where something might change, right? Maybe somebody accidentally entered the wrong MVP, and so then they could actually correct this by putting that LEDTS to a date and making that not the current record, but a historical archive tracking record, and then enter the new one with the correct MVP with a null LEDTS field. So can we go to some of the views and look at the joins on those?
Without history?
Yep.
Pretty straightforward. We're taking a hub team. We're joining it to the satellite on the sequence number. Now, one of the things that's important to understand is the load end date timestamp in the satellite table. When it's null, that means that is the current record. So if you want to show without history, for every satellite that you join to, you have to set the LEDTS to null. So it is a nice, convenient way to show history or choose not to show history. You can see some of the fields that are available, so it's just the team name or the nickname. So if you were to actually query this view, we're going to see currently, and we would maybe highlight the Broncos again, just Denver Broncos. So nothing special. This is the last update date that we had with the satellite, et cetera. If we were to look at, hey, it's important to create a view with history in it, we can simply remove the where clause where we're not filtering on the LEDTS, straightforward view where we're going across the team SQM, and we would query that table, and we would see a little bit of history here. So again, a little bit of bad news for the Broncos. Earlier in the season, a couple of executives were drinking a little bit too much and got in trouble. So somebody went in and they played around with the team nickname again, saying, hey, or the team name, they drank too much, and they're not Denver anymore, they're AA. So they did a little rehab, and we see that Denver is back to Denver. So there's actually 3 history records in this table, and so you could see what data was changed from what dates and time pretty easily from the view. Something else to highlight from a design perspective when we look at like the satellite for the team. One thing that we do want to do is with a primary key, we have a team SQM, and we're combining it with a load date timestamp to keep the data ordered for the history. So that's a really big deal.
Yeah, this is really important. So Carlos Bassi does a presentation about real-time data warehouse, and this is one of the huge concepts along with that is that really strong incremental loading based off the LDTS.
Yep, and that really helps us out. So we'll see when we're connecting the hub team, we have the sequence number, and the satellite, we have the sequence number plus the load date timestamp. So this is how we can tell on incremental loads if something has changed with filtering on the LEDTS and the load date timestamp to pull new data into our data marts. So another thing that we could compare is if we compare the data mart that we sort of showed earlier. So we had a fact player game. So if we look at all the columns, you can see we're mixing defensive statistics with fumbles, with kicking, with offensive passing, punts. All these are measures which are appropriate for players, but I guess one of the arguments you could say for this table is, I don't know many players that play offense and defense and punt and kick and do everything. It doesn't necessarily make a lot of sense. So on the data vault side, you tend to model groups of data that make sense together. So we have satellite for just defensive statistics, fumble, kickoffs, offensive statistics, touchdowns, and Peyton Manning's probably up there for leading the league in touchdowns and things like that. So really, when you model, your goal isn't to minimize the tables, it's to logically group data together so that it makes sense in your warehouse. And a lot of times, too, you might have a specific satellite table when you have data from different sources, even if it's the same descriptive information. So you can compare what one system is saying versus another system in your data warehouse. And then one last, I guess, sort of thought, again, is that your data vault, data warehouse feeds your data mart. So pulling all these tables together, you're going to load in your fact tables.
So then as we start to talk about how we implemented this, so the pros that we found with this is that we had really good load capabilities because we were doing mostly inserts. There's not a lot of updates going on. And while we just talked about hub links and satellites, there's a lot more structure, advanced modeling structures within Data Vault. We kept it pretty simple for this first presentation, but there is a lot more out there. Another pro is the incremental builds. So this really makes this easy because we were really able to do pretty much an agile method as we developed out the solar data vaults. And that's, typically sometimes it's kind of a problem with a data warehouse project is they think it's all or nothing where you really can do this incremental.
And you think about the complexities of a dimension. If you need to add some fields or change your hierarchies around, or you're making it from a type 1 or a type 2, you have a lot of interdependencies, and you might not be able to do a quick release to make a change on a report if you needed it, versus, hey, you just add another satellite table that's independent of everything else, and it's in place in your data warehouse.
Correct. And then also, again, we provide a lot of audit history and traceability with the Data Vault model. We have the ability to respond to changes rapidly within the model. The iterative build development, agile development, keeping control of your reporting and data quality issues because you've created that layer of separation because you're not doing reports directly against your data vault. So the cons, some people think there's a lot of overhead by doing the extra joins. You are adding a lot more tables, but they're thinner tables. You don't see as many columns in them. So, some developers don't like the multiple joins that you're doing. Performance-wise, they think it might be a problem. We did not have a problem performance. And you learn quickly if somebody accidentally missed a key or an index because you notice something's wrong. Ad hoc reporting, that's a problem against the data vault. We reverted back to views to allow a lot of our engineers to get that real time and for the systems that we needed it. So that's how we overcame the ad hoc reporting, but ad hoc reporting can be a problem in a high transactional environment.
And I would also say, with the use of the views, if you decide to do like a satellite split that you have rapidly changing data, you're protecting yourself against breaking reports and other things by using a view so that you have the ability to still split satellites.
And then the other question is, and every environment's going to be unique. And so in this example and how we implemented it, the question becomes, we're essentially creating 2 data warehouses is how the business looks at it, and is that twice the cost? And when we think about how we were able to respond to change, what we were giving in the portion of reporting, it really was beneficial in the environment we were in. It doesn't suit every environment. You've really got to think about what's your business like and how you want to implement stuff, but it really works for us.
And in some cases, it's not even one-for-one duplicating the data. You're applying additional data rules from the data warehouse into your data marts. So your data warehouse is raw data that you're getting from your different systems, and then your data marts, you might selectively limit how much data is in your data marts, or you might be able to summarize at a higher level in your fact tables in your data marts, knowing that the raw data is in the data warehouse. So I don't really think it's a one-to-one on twice the cost.
Right. So we're going to go into, we'll answer a couple questions real fast, and then we're going to go in and talk a little bit more about how we implemented this at the solar company. One of the questions was if we would share our database examples. Absolutely, we will definitely do that. And then, let's see, what else do we have here? If we find some hub data have different spelling variations, do we move those hub data into new satellite data?
So, you know, there's a chance that you might have picked something that wasn't a business key, and so you know, the possibility that you might look back into what you were calling the business key and why. If for some reason it really is a business key, there's a design we had in the past where we had a satellite that had the previous name of what the business key was to keep history of what it used to be. And then again, you could use the staging trick where you could have a reference table to map business keys that are invalid and convert them into valid business keys. You know, that's an acceptable way of handling that problem.
Right. And that's a good question about null business keys. A part has a make date, but some parts have a null make date. Mm-hmm. So how does that work? Is the make date not really a business key, though?
So normally not. So one of the things that you would normally never see as a hub table would be a date. A date is normally an attribute, either of the link relationship that you have between your business keys and the satellite, or a satellite off your hub. There is a couple cases on our manufacturing data where we had a link between the solar panel going through a machine on a date time, and so we had a date time as part of our link table because we knew we were going to get that because it was part of the history of the module going through the tool, because it could be resent through the tool at a different date, and that was a different relationship. So certain cases you could have dates in your relationship, but not as a business key.
Okay, so in the situation where the data is not a date but nulls come in, and I think we have this scenario with model numbers, correct?
Right. So we have issues where if it was null, then we converted it to unknown, and so we would always have, you know, some business rules how that we'd handle a null and what we would convert that as. So,
right. So we would know the date for the event that specific unknown came in, but we would adjust that to an unknown value.
Right. Yep.
Okay.
So, yep, definitely no nulls as far as the business use.
Okay. So let's go back to the company case and our implementation at the solar company. So this is an overview of the manufacturing data floor. This is considered one line. All of these green boxes are a tool on the line where the solar panel would go through it and some type of process would be applied. So for each of these green boxes, and some red boxes there too, we would be getting lots of data coming in. So every single one of these tools was feeding data up to the second. We decided what data we were going to bring into the data vault for what we needed on the business side. So we had alarms coming in, we had process information coming in, when the tool entered, or when the panel entered, when the panel exited. So we had times that panel was in certain tools. And we had experimental tools, you know, so they would be giving us feedback on panels, how much power it was, how it tested at various types of testing.
And so what you're looking at here in this picture is really a dashboard that was put on top of the data warehouse. So because of the amount of data we had and the business need to keep the data for 25 years, we created a real-time data warehouse. So this was a real-time interactive dashboard that was showing you the statistics off the warehouse.
So one of our challenges as we came up, we realized we were going to, the goal was we were going to add multiple lines to a facility, and we were going to have more facilities come online. So as we looked at just one line, we were looking daily at these are how many transactions we would be receiving, and the what those would come out to annually. So we're going to deal with a lot of transactions. So our requirements on the business perspective was we had to support a real-time engineering software piece so that the engineers could almost instantaneously see what those test instruments and what was going on with the panels. One of the other requirements was we needed to make sure that we were up 24/7 for the manufacturing line, so we were not a downtime. So our goals on the IT side was we needed to make sure we were scalable for that growth. We needed to make sure that we could deliver the data from the data vault into those data marts and the reporting areas quickly. And then we wanted to make sure that we had a really effective UI for the managers.
And one of the key things too with the OLAP cubes is some of the reports prior to our implementation were taking 40 minutes to run, just really bad performance. So this was design improvement. We needed to have the reports run quickly.
So we needed the ability to add CPU, increase our memory. We were very concerned about performance as we added more data and as we expanded. So we needed to make sure that we could see that performance as we added servers, so we could scale across servers, to scale up and scale out.
And I feel one of the design concepts that Data Vault supported was if you had to put more than one database cross servers to collect data, because you have the business key and the business key only, you could have hubs across your different SQL Server databases that remained with appropriate business keys, but additional satellite data collected on the different SQL servers, so you could scale out that way where you could actually pull the data together using multiple instances of SQL on different machines.
Right. So our loading requirements. The loading of the order of the transactions was important. We'd have alarms come in from a tool. We needed to make sure that the alarm order was correct as we received it into the database so that we had that timestamp correct. We needed to make sure that we minimized loading time. We could have a bunch of updates creating performance issues. We needed a quick close of the transaction. Sometimes on that application side how it controls an open transaction and just waiting for feedback from the SQL. And then, of course, again, we need to make sure we were up all the time. We put a slide in here for Service Broker because this is one of the things that is not used very often in SQL Server. You don't find a lot of people have implemented this. It became a great tool that was very simple for us to implement to allow us for that queuing for alarm order, allow for us to parallel that data out with the messaging and queuing, and allow for us to also pause so that we might need to do any type of maintenance. Okay. So that's kind of an overview of how we implemented things at Abound. And one of the things that we'd like to stress about this is we had a very small team when we implemented it, and we really implemented it we started off, our first couple of iterations went parallel after 3 months. And we had the first total mimic of the first system done within about 5 months with additional enhancements post that. So a very small team, turnaround on the warehouse was fantastic. So, we want to emphasize that this is very doable in a small team. Data warehouse can be super successful and be aggressive with change. Change should not be one of those things that we all freak out about. It should be, it can be done. Change can be done. So as we talk about Data Vault in our experience, know the rules and how to apply them, and don't be afraid to change things. A lot of times we went down the route of putting things into links and hubs, and then we sat back and we go, oh yeah, this isn't quite working the way we want it to. Really, this should be a satellite. Yeah. So don't be afraid to change those things because you can do it. All your data is still there. That's the wonderful thing about Data Vault. You still have your data there. So once you change those objects, you can take off running.
Yep. And I think the learning experience for me, the first time I actually architected the Data Vault was I had the propensity to see business keys where they really weren't business keys, and so I had few too many relationships. So it is a good practice when you think you have business keys to discuss and sort of talk about it as a team, and then work with the business to make sure that what you're calling something the business really calls that, and if they are, you're guaranteed that it is a business key and your model is correct.
Right. So one of the other things is this works very well for parallel transactions. There you go. So this works very well for a large amount of transactional system. I think of a lot of times of websites that this type of model would be great for when you have a lot of that traffic on the transactional side. You didn't have any locking issues because the huge amount of inserts you have on that transactional side versus updates that you would in a sort normalized. And again, we were able to apply things very quickly with this model.
And from when you choose what might be an appropriate database model between data vault, star schema, third normal form, one of the things that I feel is a good guiding direction for you is if you have mostly web input and web forms, data vault isn't an appropriate model. You'd want to go with third normal. But if you have a high amount of data coming from other systems, flat files, things like that, and you're trying to connect that data together, data vault's a really good option on that. One of the great experiences I had on the College Invest project was 95% of the data was data coming from the colleges in the form of flat files. 5% was web input. So one of the differences in the data warehouse design where, again, they required to save data for 25 years, data was coming in almost real time from the colleges, was some additional reference tables that let you provide the drop-downs in the web GUI, and then it's not hubs, but it supports some additional stuff that you might need. And then sometimes in .NET you have security, and so we added a schema on some specific .NET security so it wasn't in the base DBO schema for our analysis. So those are some tricks that you can do if you need to have a hybrid model to do some additional stuff.
So here's some links that will be useful if you are need to investigate some more Data Vault items. Dan Lindstad, who's considered the creator of Data Vault, and he has some new videos, I believe, up. Genesee Academy is where Jeff got his certification. And there's also a Data Vault group on LinkedIn. And so we'll go answer a couple questions here. In loading of a hub and satellite data parallel, or do we need to load hub data before we load satellite data? You absolutely need to load your hub data before satellite data, but the wonderful thing is you can load all your hubs at the same time. So that's where that parallel loading is coming in. So you can load all of those hubs at the same time.
So like your SSIS design patterns, you have a sequence container for hubs. All your ETL with your hubs are in that sequence container. When that's done, your next sequence container is your links. All those would be done in parallel. And then your last sequence container is the satellites. All those are done in parallel.
Right. And so then we also have the question about our team, how big our team was and what our roles were. So we basically have 3 database developers, one being the main architect and then 2 more database developers. We had an additional SSIS reports kind of cross-functional person, and then 1 other .NET developer. So really 5.
5, and then we
plus
did
a project manager. Yeah.
I
I can't forget those project managers.
Somebody had to make sure we were doing the right task, I guess. So,
okay, and so next question, is Service Broker a SQL Server product? Actually, it's part of SQL Server. So when you create a database, you do have an option to either implement Service Broker in that or implement it as a data to your application's database. So when you go and look at the properties of your database, you'll see the option in there for Service Broker and for data to your application. You cannot have them both set. You can only have one or the other or neither. Any other questions? Great. Okay, thanks so much for attending. I'm going to turn this back over to Scott.
Yes, thank you, Jeff. Thank you, Leslie. We definitely appreciate you all taking the time this evening to make the presentation, answer the questions. Again, we're very appreciative of Pragmatic Works for sponsoring this session. Just a quick reminder that the session is being recorded and you can replay it. It usually takes up to about a week to get it posted. We've got to do a couple of things with the file and then get it posted on the PASS site. So within a week or so, a recording of the session will be there. So we appreciate everyone's participation today and look forward to everyone participating in our next webinar. Thanks a lot.
Thanks, Scott.
Thank you.
Bye-bye.
Okay. Oh, good.